This lesson is for FST 4.5 on graphing sine waves. Keep in mind that sine wave is the name of both the graph of cosine and sine. It's basically the parent function name. The sine wave was probably graphed first, and the shape that it made ended up being the name that we call all waves that look like that. So you'll see it when we graph both cosine and sine, that they both carry a similar shape to each other. When you are asked to graph, you may be asked to identify intercepts, domain, range, and symmetry. Keep in mind that intercepts could be x-intercepts or y-intercepts. X-intercepts have an additional name. Sometimes those are asked as you finding where the zeros are. If you're asked where the zeros are, they're asking you to find the x-intercepts. Domain, remember, is looking at the graph widthwise or horizontally. Range is you looking at the graph vertically or from top to bottom. Symmetry, remember, is either even or odd, or neither. If something has even symmetry, it's able to be reflected over the y-axis. If something has odd symmetry, it's able to be rotated 180 degrees and look identical to the original. A few more vocabulary items. A sine wave is just the name of the shape of the cosine or the sine graph. Sometimes the book refers to that shape as being sinusoidal, so it's just another version of them calling a sine wave what shape that it is. All sine waves have a period. The period is how long it takes for the wave to repeat itself. This is not an official definition, that's just my version of how I describe what the period is. We'll talk more in detail about the period as we graph these in just a moment. This is how I introduce graphing to kids with the unit circle. We're going to be imagining the unit circle as we go, so if we want to, we can just do a quick picture of one right here. Remember that we're always starting the unit circle at point A. The x values are going to be the amount that we rotate as we go around the circle. Currently I have it set up to be in radians, but know that the shape of the graph would not change if you decided to graph in degrees instead. Keep in mind that I typically have kids memorize or learn the compass points only. Know that there are other points in between here. For example, all the different values on the unit circle can be represented, as well as all the ones that are in between that aren't represented. So for example, a 10 degree, 25 degree, 35 degree, 50 degree angle, all of those could be graphed as well. But the ones that we know by heart are the ones from the unit circle. So those are the ones we're going to use. I'm not going to make students do every single point on the unit circle, we're just going to do the compass points. Once you get the compass points down, you'll know the basic shape of the graph, and that's good enough for me. So know that it could be asked in degrees or in radians, and the y value is going to be the result of you taking the cosine of each of these. So I know that the cosine is the x value as you go around the unit circle. We're going to graph those cosines as our y value today. So if we're at cosine of 0 degrees or 0 radians, hopefully you all know that the cosine there is the point 1. If you go up to 90 now and do the cosine there, it becomes 0. Cosine at 180 or pi radians is negative 1. Down to 270 we're back to 0. Back to our starting place at 2 pi or 360 we're back to 1. So when you graph now, each of these values is going to be graphed to the line to the left of it. So this first point is right on the y-axis at 0, 1. So it's going to be right there. The next one's going to be at 0 or on the x-axis, down to negative 1, back to 0, and back up to 1. It looks like a V shape, but do not connect it with a straight line. Remember that there are other points in between the ones that we just showed, and those points, if graphed, would form a curve. So when you graph these, it's very important that you make it look like a curve. So what I'd recommend that you do to make the picture look accurate and symmetric is to take these three right here and just form a bowl shape or a U shape. Try to make it look as symmetrical as you can. Then the upper part is supposed to be the upper part of the wave, but it gets cut in half and those two pieces are reversed. So this part is going to go here and that part is going to go over here. Know that the graph does continue to complete its cycle, and it would look like that. So when you're trying to recognize cosine or sine, you should know that the cosine wave starts up at 1, goes down, and then dips back up. So the basic shape of the cosine wave is the U shape. For the domain and the range and the intercepts, let's go through those. The domain here is what kinds of x's could you use. The x's could go on forever to the right, they could also go on forever to the left. So the domain here is all reals. The range, however, the height of the graph top to bottom, is just from -1 to 1. The x-intercepts, remember, are where the zeros are, or where the zeros occur, and they occur at 90 and 270. Keep in mind that those do continue past what we've drawn here. Those will be repeated again every 180 degrees. So I'm going to put a dot 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 here to indicate that there are other x-intercepts other than what we've written. I usually tell kids to memorize the 2 x-intercepts for cosine just as you go around the circle one time. So 90 and 270 is sufficient as long as you indicate that there are others. To try to remember that, I just drop the zeros on those. 9 and 27 I consider odd numbers. So when I think about cosine, I think about the x-intercepts being the odd values as you go around the circle. The y-intercept is clearly at 0, 1, or you could just say at 1. We also need to talk about the symmetry. Symmetry is not as easy to identify on this particular picture. If we did draw another wave, you would see that the graph is symmetrical to the y-axis. So this has even symmetry. So you might not be able to see it right now, but when you see the full graph pictured both to the right and to the left, it would be much easier to identify. The period is how long it takes the graph to repeat, or the wave to repeat, and it starts to repeat itself as you start to go around the circle again. So that would be 360 degrees, or 2 pi if you're doing it in radians. So now let's contrast that to the sine graph. The sine graph, if we graph it in the same way, in the same fashion, just means that we're going to graph the y values as we go around the circle. So the sine is going to be at 0 degrees, or 0 radians, is going to be at 0. Then it goes up to 1, back to 0, down to -1, and back to 0. So when we graph the sine coordinates, we get similar outcomes, but now the wave starts at 0, 0, goes up, and then goes down below the x-axis, and then comes back up. So this is where the original wave shape got its name as the sine wave. It looks like a wave. It comes up, comes down, and then comes back up to its original spot. The domain and the range for the sine are the same as for cosine. So it goes from -1 to 1 for the range, and it has a domain of all reals. The x-intercepts, however, are in a totally different location. Those are at 0 degrees, 180 degrees, and 360 degrees, and those also repeat every 180. So I like to think about these as being the odd multiples, where the cosine has the even multiples, where the cosine is the odd. The y-intercept is also different. The y-intercept for here at sine is at 0, 0, or you could just say 0. The symmetry here is not even. If you were to complete another wave going the other direction, you'd see that it has rotation symmetry, so we call that odd symmetry. Again, you wouldn't really be able to recognize it as is. We would need more of the graph in order to adequately see what kind of symmetry it has. Period is the same, so the period is 360 degrees or 2 pi. And again, that's just basically the function of the circle itself. As you go around the circle, you only need to go around 360 before you start to repeat. So the domain and the range and the period are the same for both graphs. They both are called a sine wave, but they have different x and y intercepts and different symmetry. A typical type of question that students are going to have to do is something like sketching the cosine for -360 for theta up to 720. It's very important for students to understand what this is asking. This is asking you to do 3 periods of that graph. Remember, from 0 to 360 would be the one period, that's the one we just did, and then from 360 to 720 would be another time around the circle. Going from 0 back to -360 would be another time around the circle. So let's just make a quick sketch of what that would look like. So give yourself your x and your y axes. know that we're going to need a big x-axis because we're going to do 3 periods. Remember that for cosine, it starts up high and dips down and comes back up. So we're going to need to do 3 of those right next to each other. So I'm going to make a cosine graph to start, trying to make it as symmetrical as I can. And then I'm going to do another one right next to that, and I'm going to try to keep it the same look. And then I'm going to do another one going back the other direction. And so I've done 3 waves now, trying to keep the range top to bottom the same and trying to keep the period the same going from right to left. To give this a little bit more oomph, we're going to just put in where those x-intercepts occur at 90 degrees and 270. So that makes the graph a little bit more accurate. Same thing here with the y-axes. I'd put in my -1 and 1. So it doesn't have to be a perfect graph. I used color there to help try to illustrate that I did indeed draw 3 periods of the graph. They also may ask you follow-up questions about your graph. For example, where is the cosine equal to 0? Basically what they're asking you for there is where are the zeros or the x-intercepts. So we're going to need to give 5 of those. I have 2 already. Remember that they repeat every 180. So if I go back 180, that's going to be at -90. Another 180 past that is going to be at -270. And then I just need to do one more. So let's add 180 onto 270. So I know that's going to be at 450.